Well, thank you. Pleasure to be here. Yeah, you summed it up very well. Matter of fact, I don't know if I have too much more to say, but I do. Believe me, I have a lot of slides that I'll be presenting to you today. Just to clarify a little bit, I was the chief meteorologist since 1989. I became the senior chief 4 years ago, and that's when I went part-time. And so we have a new chief. He does all the work. I get all the credit as the senior chief. But I just work occasionally now. I worked this past weekend. It was only my third time working this year. But I love it. I enjoy television and broadcast television. So I've been blessed to have such a long career. But over the years, I did notice, as I was doing my job, concentrating on the next 7 days of weather for my viewers, I was keeping track of what climate scientists were saying and the research they were putting out, and noticing how really alarmed they were becoming on what was happening in our climate. But I also noticed that there was a disconnect with the general public. Much of the general public didn't share that alarm. So I was like, what's going on here? Why aren't they concerned like I am and climate scientists are? And I delved into it. I found out how much misinformation is out there, that the fossil fuel industry has been instrumental, unfortunately, in putting out misinformation enough that people were just confused, not really knowing what was happening. So I decided to use my position as a scientist. For many viewers, I'm the only scientist that they see and know, but use my relatively trusted position to go out and talk about climate change, and not only to groups like you, but on air as well. So let's get into it. The 6 Americas of climate change. And what this is going to show is the relative concern that people have about climate change. And it shows that this is back in 2014. It was not very encouraging back then in terms of being alarmed and concerned, cautious. There was a significant percentage of disengaged, doubtful, and dismissive. So dismissives, you can't tell them anything. They're trapped in their echo chamber, can't get them out. But when you get away from the dismissives, at least you have people that are willing to listen. But we've had an encouraging trend, though. And it does show that this is as of 2022, I believe, 2021, how much we've seen an improvement. The number of people that are truly alarmed, the percentage is much higher. Concerned folks are, there's more there as well. And the disengaged, doubtful is somewhat less. Dismissives have dropped as well. So that's always an encouraging sign to see, and the trend continues to be in that direction. To sum it up, our climate is the following: simple, serious, and solvable. So that's how I'm going to be breaking up my presentation today. Let's talk about how simple it is. In the scientific world that I live in, when you get away from the political world and the discourse that goes on there, these statements are unquestioned. That climate change is real, it's us causing it, it's dangerous, scientists overwhelmingly agree, and very important, we have solutions that are technically feasible, economically affordable, and politically viable. Talking about human cause, how widely agreed upon climate change is among climate scientists, 97% of actively publishing climate scientists agree that human-caused climate change is happening. What about that 3%? I think that's the fossil fuel industry and scientists that are in their pockets, unfortunately. But when it comes to peer-reviewed research that's issued, virtually 100% of all that research states that human-caused climate change is happening. So within our world, there's no question whatsoever about those statements. So what made our climate change over the millennia? We've gone in and out of ice ages, as you know, and we've seen our world transformed incredibly over thousands and even millions of years. It was sunlight intensity that changed our climate. And how did sunlight intensity change? By wobbles in the Earth axis, by changes in the Earth tilt, and in changes in the Earth's orbit around the sun. Those three actions did cause our sunlight intensity to change just almost imperceptibly over thousands of years. But over thousands of years, it was enough to change our climate. What's happening now? Well, the red line is the average global temperature since 1880, and you can see how it's been climbing exponentially since especially the 1970s. The yellow line is solar intensity, and it's been decreasing. According to climate scientists, we're in one of these cycles where the natural processes of the wobbling, the tilt of the Earth, the change in the Earth's orbit is bringing our sunlight intensity down. So, no, it's not natural process at all. It's not sunlight intensity and its change that's causing our atmosphere to warm. So what's going on? The atmosphere is 99% nitrogen and oxygen, but it has these trace greenhouse gases: water vapor, carbon dioxide, methane, and nitrous oxide. And it's the greenhouse gases that actually make our Earth livable. If we didn't have greenhouse gases in the atmosphere trapping the heat from the sun, then we'd literally be an ice ball. So the greenhouse gases have made our planet very livable. The problem is, now water vapor does not change its concentration. It goes through the water cycle, but we haven't seen the concentration of water vapor change. But we have had increases in concentration of carbon dioxide, methane, and nitrous oxide. It's an old science that greenhouse gases cause the atmosphere to warm. And these four scientists, Joseph Fourier, Eunice Foote, Svante Arrhenius, and Guy Callendar, all had their part in just furthering that science. So back in the 1800s, they knew, yes, carbon dioxide, warming our atmosphere. As a matter of fact, Svante Arrhenius projected what's happening now, way back then. So it's really simple, actually, that carbon dioxide and those greenhouse gases, the reason that they're increasing, and the scientists back in the 1800s knew this, is because of the burning of fossil fuels, the burning of oil, the burning of coal. That's putting more carbon dioxide in the atmosphere, along with the other greenhouse gases, and that is causing the average temperature of our atmosphere across the world to rise. Climate scientists, they need to be able to put everything in proper perspective. They need to understand, okay, how does what's happening now relate to thousands of years ago? And they've been very clever in the way they do that. What they've been able to do is drill ice cores into the ice in the Antarctic and in Greenland as much as 2 miles down. University of Wisconsin has actually been one of the forefront leaders of this kind of effort. So they've extracted these ice cores as much as 2 miles down, which puts you 800,000 years into the past. And in those ice cores, you have bubbles. That bubble still has the air chemistry back then, okay? So we get an analysis like this. Kind of hard to see, especially if you're off on the sides. But I'm going to step away from the mic just for a moment. But the bottom line is going back 800,000 years. The top line is CO2 concentration. And for most of that millennia, the concentration was between about 200 and 300 parts per million. Until very recent past, we've had this huge spike occur. So what's going on? Why is it bouncing here, back and forth? That's a natural processes. The sun intensity is changing. The oceans are cooling and warming. When you warm the oceans, they absorb CO2. When they cool, they release CO2. So you get those natural variations. But there's nothing natural about that spike at the very end. And this is, again, what makes climate scientists so alarmed. And that, in turn, has caused our atmosphere to warm. Do you have a question?
Yeah, what is sun intensity?
Sunlight intensity. Yeah. It's literally the energy of the sun as that comes to the earth. That has changed. When the energy from the sun as increases, as you get infrared radiation coming at us, and other radiations, then that causes the earth to warm, okay? So we're seeing a decrease in that amount of energy that's been reaching the Earth. So we've had this increase in CO2 concentration, and it corresponds with an increase in the atmosphere and its warming, as we might expect. Now, this goes back 2,000 years. The white line represents actual measurements. The yellow line represents reconstruction from a lot of its climate modeling. And I forget the exact name of how they were able to do that analysis, but they were able to reconstruct that. You can see again how we've had this incredible spike happen in a very short period of time. Expanding that spike out a little bit. So we're starting in 1880, which is essentially as far back as they can measure the average global temperature every year. You can see the blue line, it's bouncing up and down. That is natural variation taking place. El Nino and La Nina. You might have heard those terms. Right now we're in an El Nino, where the equatorial Pacific Ocean waters at the surface are much warmer than normal. And that drives changes. La Nina is the opposite. It's colder than average ocean waters. So there's a lot of that involved in the overall bouncing up and down, but the overall trend is clearly there. And again, it's not linear, it's exponential. And it corresponds with carbon dioxide concentration and its increase. And it's just what climate scientists would expect to see happen. Methane concentration has gone up significantly too. One thing to remember about the greenhouse gases is how strong they are. Methane is essentially 80 times more powerful than CO2, than carbon dioxide. Nitrous oxide is even a stronger greenhouse gas. One thing about methane, thank goodness, it only lasts in the atmosphere 10 years. Nitrous oxide, 100 years. The big problem is carbon dioxide. It stays in the atmosphere over 1,000 years. So once it's there, we're at a new normal. We have to deal with it. The only way to change that normal is to extract the carbon dioxide, which I'll get to in a little bit. But this warming of the atmosphere has put us so much warmer than normal. So all those red lines represent year by year departure from the 1881 to 1910 average. And you can see a few blue lines down there, but they're not very many. And basically after World War I, we haven't had hardly any at all. And again, the climbing of that average temperature compared to normal has been steady and uncompromising to the point that 2023, as you might have very well heard, was the warmest year on record, closing in on 1.5 degrees C, about 2.5 degrees Fahrenheit. What are the 10 hottest years on record? The last 10, okay? And 2023 was the hottest, driven in part by El Nino. Again, there's natural processes going on here, and El Nino did help to push it above 2016, which was another strong El Nino year. Departure from normal for the entire Earth. Orange shading is above normal, blue shading is below. Not much blue shading on that map from last year. So this warming has had serious implications. Our seas are rising due to the melting of land ice, of glaciers primarily. But we're also seeing wild weather. We're seeing extreme weather events because warming the atmosphere supercharges it. And that supercharging manifests itself as extreme weather events that are becoming more intense and more frequent. Let's zoom in a little bit though. Let's get away from the global perspective and talk about what's happening here. And this is since 1970, how much in degrees Fahrenheit we've seen our local temperatures rise, our average annual temperatures. And it shows for the United States 2.5 degrees, which kind of matches the world. But Wisconsin's 2.6, Madison is at 3. Wisconsin and Madison are warmer than the United States in general because of the influence of the Arctic. The Arctic is the fastest warming region of the world. And especially during the winter, we feel that. Madison's set by record by decade. Record lows are blue, record highs are in red. Now the trend is very clear. Into the 1940s, there was this equal balance between record highs, record lows, but now it's all record highs. Our season is not equal, though, in terms of the warming that's taking place between spring, winter, summer, and fall. Winters are by far our fastest warming season. In Madison, it's over 4 degrees Fahrenheit warmer than it was back in 1970. And you think about it, 1970, that was just a little over 50 years ago. And we've had that much warming in that short a period of time. So the end effect is our summers are getting longer, our winters are getting shorter. And this winter is an excellent example. One of the ways it really is shown is in the coldest temperatures we experience every winter. Back in 1970, our average coldest temperature was 20 degrees below zero. Now it's 12 degrees below zero. So it's 8 degrees different. And again, climatically, this is just a snapshot of time. And that has had impacts in many ways. We're having shorter cold spells. On average, our cold spells last a week less than they did back in 1970. So this has given us all kinds of problems. More disease-carrying insects survive, just not cold enough to kill them off. We have earlier blooms and more pollen that starts earlier as pollen gets going earlier. We have less snow and less ice. We had a disastrous year in Wisconsin economically through the winter. Here in southern Wisconsin, yeah, it was bad. Northern Wisconsin, it was catastrophic. They had less snow than us. You think about it. For ice fishermen, their season was really short. Even for downhill skiing, where they make snow, but it was so warm that they couldn't even make enough snow for much of the year. So a bad year. I'm a cross-country skier. Love to cross-country ski. And I cross-country skied 2 days this year. It was on the tail end of when we had all that snow. I'm thinking, oh, great. But then it was so bitter cold I couldn't get out. And by the time it did warm up enough, it was the following weekend, I got out that Saturday and Sunday, but by Monday it was just so dang warm again that I couldn't get out anymore. So we're feeling all these impacts in our winter season. But it carries into spring. Evolution has not kept up with climate change. So there's mistimings taking place in insect pollination, in birds' food supplies being disrupted. Again, plants are sprouting earlier. We're getting that allergy season going earlier. We have crop damage. In the last decade, we've had major crop losses in vineyards and also fruit orchards. When we get this warm spring, then you get a killing freeze following, and you get all kinds of damage. So we have these serious things happening. I haven't even touched the rest of the world. I could spend another hour on that, but I just want to, emphasize locally what we're experiencing. But you can break it down a little bit more. Nature, health, economy. Let's talk about economy. One way to measure these extreme weather events is in the number of billion-dollar disasters that occur. That's a metric that can measure. If you have a billion-dollar disaster, you have an extreme event that's happened. And one way to look at it is the frequency of how often billion-dollar disasters happen. Back in the 1980s, it was 80 to 100 days between, but now we're down to 10 to 20 days between these billion-dollar disasters. And 2022 was bad enough, 2020. Here's 2023, we had $28 billion disasters, by far the most that we have ever seen, okay? And climate scientists are saying, hey, you're going to see more frequent and extreme billion-dollar events like this, extreme weather events. And they run the gamut: drought, flooding, hail, hurricane, severe weather, tornadoes, wildfire, winters and storms. Climate change was not the primary reason for any of those events, but it was a contributor. It made them worse, and it brought some of those events into that extreme category that they normally wouldn't have been. One big area of climate science now is in attribution. So they can, after that event occurs, they can research it and figure out what was the contributing amount that climate change had on that particular event. The impacts in health are many, including injury and death, ultimately. Mental health is a big one. Heat stress, insect-borne diseases, lung disease, and allergies ultimately are impacts from climate change. This map is hard to figure out. It's the tornado tracks from February here in southern Wisconsin. We have Greene County here, Rock County here, hard to make out. But there's Janesville and some communities that were almost hit directly, very close to being struck directly. Thank goodness they weren't. But we had an EF2, we had another EF1. EF2s are a strong category tornado. We'd never seen a tornado in February before this year, and we saw 2 of them. Thank goodness there weren't fatalities, but we were just lucky where the tracks were that they didn't go directly over significant towns. The major impact that we have locally in terms of extreme weather is from catastrophic rainfall, extreme rainfall events. Scientifically, this is what you'd expect. For every 1 degree Fahrenheit increase in the average temperature, you get 4% more water vapor. Madison, we've increased 3 degrees since 1970. That means on about 12% more water vapor up there. So when you get storms coming through, they have that much more water vapor to work on and help produce extreme rainfall events. And we had a doozy back in 2018. Kind of hard to make this out, but you recall Middleton, you recall the west side of Dane County, Mazomanie, Black Earth, all the damage that occurred in those areas. The all-time Wisconsin record for 24-hour rainfall is 11.7 inches, set in northern Wisconsin back in 1946. Unfortunately, they couldn't get an official measurement in that area, but we're pretty sure it exceeded it. This is an example of the extreme rainfall events that we're going to see more of. We've been lucky that it's been since 2018, but the frequency of these kind of events will occur. And I'll mention this, if that bullseye had occurred in Madison on the isthmus, imagine that, 12 inches of rain in 24 hours on the isthmus, most of it would have been underwater. We were lucky that it occurred where it did. And one that you might not think about, but it's there, is that algae blooms are more frequent now in our area lakes. We have more frequent heavy rainfall events. We're still fighting with all the phosphorus, what's put into the soils by farmers, that runs off. And also the lakes are getting warmer. Perfect ingredients for algae blooms to increase. The lower left, kind of hard to make out, but that's Lake Mendota. That was early in the spring last year. We had this huge algae bloom in Lake Mendota that covered a good half of the lake. And of course, our lake closures, our beach closures are getting more and more frequent every year. One you might not think about is poison ivy. The toxicity of poison ivy has really increased since, for some of us, around when we were born, back in around 1950. Just from then to now, the warming of our atmosphere has caused, poison ivy loves our environment. So it's getting more and more toxic. It's saying, yeah, bring it on. So we're at 40.9 milligrams approximately today, but it's projected if we continue business as usual, it'll go over 50 milligrams, could be almost double by 2060. I had poison ivy twice last year, and I can attest it is nasty. It takes forever to get rid of. I'm firsthand can tell you how toxic it is. So watch out when you take those hikes. This is one that's made the headlines lately. Deer ticks are starting to really come out now, much earlier than normal, okay? Because our spring has been, late winter to spring has been so warm. So Lyme disease is going to be more and more of a problem for us as we continue to see our atmosphere warm. And mosquitoes, the average mosquito season is 3 weeks longer than it was back in 1980. Again, this is an average. It goes all over the place year by year. In 2023, I think it was a below average year. But overall, the trend has been looking like that. And allergies. Asthma has increased so much. We have a longer and more severe allergy season. And this is especially impactful for the young, for the elderly, for those that are sick and ill. It's a big problem that's just going to get worse because our growing season is about a month longer than it was back in 1970. Okay, a month longer. And so all the plants that cause pollen have had that much more time to produce their pollen and become a problem. Expanding the view out one more time as to what are the impacts as we go forward. So we're right around 1.4 degrees C increase over pre-industrial levels, about 2.7 degrees Fahrenheit. If we stay consistently at 1.5, you have the impacts that are listed on the left side, including sea level rise, coral reef destruction, people displaced, exposed to severe drought, and sea ice, well, at least one sea ice-free Arctic summer after 100 years. But I just saw some new research that it could be as near as 10 years from now at the rate things are going. You don't want to hit 2 degrees C. If we go up just another half degree, you're adding more sea level rise to the point where 10.4 million people are exposed to that rise and have to move. You have virtually the entire coral reef ecosystem disappears. Over 400 million people in urban areas are exposed to severe drought, and at least one sea ice-free Arctic summer after 10 years. The 410 million people exposed to severe drought, so what happens to those people? They move, right? So you're gonna have more of these migrations of people, especially in equatorial regions, which are most affected. The incredible social disruptions that will cause us. So where do we go from here? All up to us. And what we do in regards to pumping greenhouse gases in the atmosphere, curtailing that, eliminating that, will make all the difference in the world. Unfortunately, we've used up all of our cushion. We're at make or break time here. So substantial cuts are showing if we can really reduce and eliminate the increase of greenhouse gases in the atmosphere, eliminate it, then we can stay below 2 degrees C. Climate scientists are pretty confident of that. 1.5, it's going to happen consistently. I mean, we were very close this last year, but we're going to be right around it on a consistent basis. If you do no emission cuts, if we have less effort than we have right now, we could be up around 4 degrees C by the end of the century. I just think about my kids and grandkids when I see this map. You know, where are they going to be if it hits 2 degrees C or 4 degrees C? That worst case scenario, that red line, just to put in better illustration, for Madison, our average temperature in Fahrenheit in the summer will be 11.5 degrees hotter, giving us the average summertime temperature of Alexandria, Louisiana. Now, I don't know about you, but there's a reason I live here and not there, you know? But just think about it. It's just not the heat that we'd have to deal with. Think about vegetation, bugs. I mean, our whole ecosystem will be nothing like it resembles right now. So we can't let that happen. Fortunately, it is solvable. The challenge, though, is that greenhouse gas emissions in the United States, in particular, are broken up throughout the entire economy, including agriculture, commercial, residential, industry, electricity, and transportation. Transportation became larger than electricity just in the last few years. So we have to address all of these different economic sectors if we're going to level it off fast enough. One big thing that we can do, kind of low-hanging fruit, is reduce our electricity consumption, reduce your carbon footprint. One big way is through better buildings. And there's effort going on here, but there's a lot we can do to make our buildings more energy efficient. putting in glass that's more efficient, insulation improvements, electric heating and cooling, getting away from any kind of natural gas. Natural gas produces methane, and methane is, again, much more powerful than carbon dioxide. The fossil fuel industry will tell you, well, it's a nice bridge fuel. No, it's not. It's a fossil fuel. So we have to eliminate that and get to true ways to reduce those emissions and get to renewable energy. There's low-hanging fruit, what you can do in your home. You can make a big difference just there. When it comes time to replace a furnace, high-efficiency heat pump. Make sure your insulation is at its best. Energy-smart appliances, smart thermostat, LED lighting. Just doing those can save significantly. I'm not even talking about putting solar on the roof, but you can reduce your utility costs on average for Wisconsin over $500. And just as important, if not more so, you are taking 3 tons of CO2 emissions out of the atmosphere. So things you can do. Electrifying transportation, going back to the United States sector more. Big one. Again, it's the number one one that we have to deal with in terms of it's so impactful. You might have read that Biden just put out a new plan through the EPA to really restrict even more tailpipe emissions for the U.S. industry. Huge. If we can keep that in place, that's a big if, then that will really help the transportation sector. We need that. Agriculture is unfortunately a significant source of greenhouse gas emissions, especially nitrous oxide because of fertilizer that's spread on the ground. But they can do things as well, grow cover crops, apply compost, reduce tilling. There's a documentary out called Kiss the Ground, which is excellent and really goes into agricultural impacts and what they can do to change things around. And nature has its own carbon sinks that absorb CO2, and that includes grasslands, coastal wetlands, peatlands, and forests. And fortunately, we've been seeing them disappear. We have to stop that progression and just start expanding them. And that will help significantly. And there's something that you can do personally, and that is eat less meat, eat more plant-based foods. Just eat more as a vegetarian. So on the right side of that dotted line, kind of hard to see, small type, but the far right is beef, blue is water consumption, green is land use, orange is greenhouse gas emissions. You see where beef is, right? But all of the animal-based foods have significant issues. On the other side of the dotted line are the plant-based foods. So the more you can eat as a vegetarian, the more you're going to help our planet. And I'll tell you, I was a meat eater like no one else not that long ago. But with the help of our vegetarian daughter, I've been eating more and more vegetarian and finding out how good it is, you know? So we eat significantly more as a vegetarian ourselves. But the bottom line is we have to make this transition going away from fossil fuels and going to renewable energy, thank you, at a faster rate than we are right now. It's happening, but it's not happening fast enough. There is nuclear. Controversial to say the least, right? And understandably so. However, there is a lot of research going on to make it viable again, especially in making these micro nuclear plants. It's much smaller, much more manageable. So I'm holding out hope that they can figure it out and make it more affordable, because that would help if we can get nuclear back on board. But the big ones are wind and solar. Hydroelectric is not nearly as significant, but still a player. Geothermal's a player as well. But these are the big ones, wind, and solar. And the costs, as you know, have dropped so much in the last 10 years. It's now cheaper to put solar panels up and windmills than it is to make a coal-fired plant. So we don't see coal-fired plants being built anymore. The problem is we are seeing natural gas plants being built, but at least the trend has been good. And it all comes down to cost disparity. I mean, it's economic forces that are doing this. The costs of burning coal and making a coal-fired plant and burning oil are higher now than it is to have a solar plant or wind as your sources. But the cost disparity has to be more to make this transition over to renewables happen at the rate that needs to happen. FFRF is now part of the solar savings plan. That's part of MG&E, I believe, that they have. FFRF is doing its part. Also, you're replacing your lights and going LED here. Oh, they're all LED now. Excellent. So that's great to hear. We need more organizations to do what you've been doing. Now, there is a game changer that happened last year by the Biden administration, and it was called IRA, the Inflation Reduction Act. You might be familiar with that. And it's billions of dollars that are helping to incentivize renewables, make them even more affordable, okay? A lot of it's tax breaks and the like. But the IRA, if it remains in effect, which is a question mark, but if it does, we can, by 2030, by the end of the decade, be 50% below annual greenhouse gas emissions compared to 2005, which is, or almost at 50%. It almost gets us to that 2030 target that we should try to get to. If it stays in effect, it's really going to help the cause of making this transition happen faster. And just to give you an illustration, IRA in the different areas will reduce electricity production by 37%, transportation by 30%, industry by 13%, carbon land sinks, which would be expanded, 9%, and buildings 6%. So good news there. There's another way that legislatively we can help the cause in a big way, and that's putting a price on carbon. Economists have been saying this for years. A carbon price is the single most powerful tool available to reduce Americans' carbon pollution. Because you think about it, billions of dollars of damage are happening every year. Who's paying for that damage? Insurance rates. Our government is doling out money. People are just are losing homes. So that the cost of that damage, if we put the true cost of what fossil fuels really cost by putting the economic damage that they produce in there, then you get a huge disparity of costs. The fossil fuels become so much more expensive than renewables. And there's legislation that's out there. It's called Energy Innovation Carbon Dividend Act. Citizens Climate Lobby, which is a nonprofit that I belong to, really pushes this. But the idea is to charge a fee on fossil fuels at the source. Now, when you do that, yeah, fossil fuels become really expensive, but inflation takes off too, right? As this transition occurs. But if you take the fee and give it back to us as a dividend, then that really mitigates that inflationary cost to us and makes it doable. It makes it really, it can happen. But yeah, the benefits are we get to net zero by 2050. Affordable clean energy, save lives, puts money in your pocket. The problem we have is the way Congress is right now. Trying to get, we almost came close to passing it actually last year, but it didn't happen. So it's going to take a while for this. Hopefully it'll still enact, it's just a matter of when. But there's another area which really holds out hope, and that's what's called climate restoration. The goal is to reduce the level of carbon dioxide and methane in the atmosphere to pre-industrial levels using a wide array of technologies now in development. Direct air capture. You might have seen this story on 60 Minutes about a month ago. They had a nice article on it. And it's literally you run fans, the air goes through the fans, it takes the CO2 out of the atmosphere, and then they take the CO2 and pump it into the ground. It's not scalable yet, it's not cost viable, but they're working on it. Convert landfill methane into RNG. Does that sound familiar? We're doing it. Dane County is one of the few counties in the entire country that has, and matter of fact, it's what Dane County has done overall, I'm just so impressed with. But in this particular instance, because methane is one of the biggest producers of methane are landfills. But all that methane from our landfill, Dane County landfill, is converted and made into renewable natural gas. And the fleet trucks of Dane County use it, Quick Trip uses it. So it's really a significant technology that's working right now. And I know there's a lot of counties that have come in to Dane County, hey, how are you doing this? And they're trying to do it as well. Convert garbage into sustainable aviation fuel. There's actually a company in Madison that is doing that. But a lot of it is just scalable, making it affordable. And that's where they have to get to yet. There's regenerative agriculture, ocean atmospheric methane removal. And I'm not going to get into all these, but grow kelp forests in the oceans. It's like planting trees, except you have kelp doing the job. And carbon mineralization using enhanced rock weathering. Literally, you spread these rocks out on the surface that are super absorptive of CO2. And that's one way to extract. So there's a lot of, and there's more, but there's a lot of hope out there that we can use technology to literally extract carbon dioxide. Quite frankly, it's my personal belief, we're going to need that help if we're going to keep ourselves close to 1.5 and not get ourselves up towards 2.0. What about China? Good question. China is the #1 producer of carbon dioxide in the world right now. We need China just as much as we need any country if we're going to make this. We need the entire world on board, right? Well, keep in mind though, top CO2 emitting countries since the start of the Industrial Revolution, by far, it's us. The United States has produced twice as much CO2 into the atmosphere than China, and much, much more than other countries. So we can look right at ourselves as to the predicament we're in right now. Part of the problem for China, and this is now where we stand, China is by far the #1 producer of carbon dioxide in the world, almost twice as much as the United States, but we're electrified. China still is not totally electrified. They're still in that process, okay? So they're under tremendous pressure. Yes, they are building coal-fired power plants yet. However, if you look at electricity generated per year by solar and wind, look where China is, far ahead of the United States. They are, yeah, they're building coal-fired power plants, but they're producing solar like crazy. They're producing wind mills like crazy. The point here is that I say, let's get our own act together. Well, don't point at China. We're the #1 economic driver of the world. What we do makes other countries follow. So let's get our productions up where China is. And another one is just, share of electric vehicle sales among all passenger vehicle sales. We're at 8%. China is at 29%. So again, they are much farther ahead of the game than we are. So that's what I have to say about China. Yeah, China's a big problem, but we're a big problem too. So we've done a lot of big things before, especially in the areas of technology. We've done moonshots, getting the entire United States behind it. What can you do? What can you do personally? #1, have conversations with your family, friends, and neighbors about climate change. Hopefully this spurs you to have those conversations. It can be difficult sometimes, right? There's a lot of politics, unfortunately, intertwined with climate change. It shouldn't be that way, but it is. Vote for candidates that advocate for climate change solutions. I don't care if it's a school board, a village, city, town, state, or federal. What is the position of each of those candidates on climate change? And make sure that factors into your decisions. And join an environmental organization. It's, as an individual, you feel powerless. But when you join a group, that really changes things. There's Sierra Club, there's 350.org, there's Citizen Climate Lobby, among many organizations out there that you can join and help change things around. Because, yeah, our federal government is so screwed up right now, right? It seems like hardly anything gets done, even though they did pass IRA somehow. But as a grassroots, what can we do? You know, Dane County's done amazing things. City of Madison is at the forefront. Middleton is. We have to concentrate and do what we can do. So it's simple, well-understood science that goes back to the 1800s. It is serious. Impacts are already being felt and will only accelerate, but it is solvable. We have what we need to make changes. This is Cheryl and I with our 3 grandchildren. This is why I'm here today talking to you, right? I think that's why many of you are sitting here right now. You're thinking about your kids. You're thinking about your grandkids because you look at those curves, end of the century, where can we possibly go? We can't go there. So it's up to us to help them. It's not only our grandkids, but it's the children all around the world. Thank you.